Well, welcome to our fourth and final part of this presentation on maximum circuit current. And in this part, we're going to talk in a little bit more detail about inverter output and EPC input maximum circuit current. So starting off with inverter output circuit maximum current, the NEC 690.8A1E and 705.28A tell us that we need to use the continuous output rating of the device, in this case, to determine maximum circuit current. So in the case of this particular inverter that we see on the slide, we can see the specs for that inverter on the right side here, and we see the AC maximum output current for this inverter is 100 amps. And so that is what we would use for the maximum circuit current value for the output circuit of this inverter. And we're going to use the manufacturer's spec sheets to determine that, or the labels on the inverter. Just information has to come from the manufacturer. And there's no need for that additional 1.25 safety factor that we had to use when we were calculating PV source and output circuit maximum current, because the inverter can't produce any more than its maximum ratings, and that's per the listing of the inverter as well as the way the inverter is designed and programmed. It's not going to exceed the output ratings that you see on the label or on the spec sheet. Microinverter output circuit maximum current is same in concept as the previous inverter that we were just looking at. So maximum current is going to equal the manufacturer's rated maximum output. So in this case, on the example we see on the bottom left, maximum continuous output current of this microinverter is going to be 1 amp at 240 volts or 1.15 amps at 208 volts. And so typically, these inverters are wired together, connected in parallel, and the total amount of current is going to depend on the total number in parallel in a given circuit. In most cases, this is going to be limited by the manufacturer, and you can see here on the bottom of this example part of this spec sheet, the maximum units per 20 amp branch circuit is limited to 16 at 240 volts or 13 at 208 volts. So you can't have any more than 16 microinverters connected together on a single branch circuit at 240 volts or more than 13 at 208 volts. Now we're going to look at this maximum input current of EPCs and what we're allowed to do under 690.8A2, just in a little bit of a brief context here. So basically this section allows us to possibly size our conductor ampacity less than the maximum circuit current in some scenarios. So circuits that have OCPD, overcurrent protection device, with less than or equal to conductor ampacity, that's one of the stipulations. If you have a circuit that's protected with an overcurrent device that doesn't exceed the conductor ampacity, your maximum circuit current is permitted to equal the rated input current of the converter, or the EPC, the DC to DC converter, the inverter, whatever it is. As long as you have the overcurrent protection in place and it doesn't exceed the conductor ampacity, you can use that rated input current of the converter instead of the maximum circuit current from the array. For example, there may be a high array current to EPC input ratio, and so in this case we're looking at a PV output circuit of 67 amps short circuit current times 1.25 irradiance factor, and that gives us 83.75 amps maximum circuit current. If that's connected to an inverter with 60 amp usable input limit, we can verify that the input is within the EPC manufacturer maximum limit and potentially use that number, 60 amps, as our input current number to size our conductors. And then just a side note here, just looking at 690.9a, conductors sized in accordance with 690.8a2 are required to be protected against overcurrent with overcurrent protective devices. That concludes this last part of our presentation on maximum circuit current. Thanks for paying attention and hope you enjoyed this lesson.